Welcome to qnawire.
Hi, so in this case what we have is a spacecraft that at rest has a length equal to 100 meters, and we're asked that at what speed would the spacecraft have to be traveling to appear 1/4. So this is the longitude at rest. So what we want is that L is equal 1/4 of L0, right? Which would be equal to 25 meters. So in special relativity, what we have is that the length of an object, the apparent length of an object, is equal to the length at rest divided by the Lorentz factor, which turns into L0 times 1 minus the velocity of the object divided by c squared. So essentially, what is required in this problem is that the square root of 1 minus b squared over c squared needs to be equal to 1/4. So from here, what we can directly see is that 1 minus b squared over c squared needs to be equal to 1/16, because I'm simply taking the squared on both sides of the equation. Next, b squared, let me go down a little bit. We can isolate b squared over c squared, needs to be equal to 1 minus 1/16, which is equal to 15/16, of course. So from here, what we have is that 16 times b squared needs to be equal to 15 times c squared. So b squared needs to be equal to 15 over 16 c squared. We can take the square root on both sides of the equation. So velocity is going to be equal to square root of 15 over 16 times c, which we can further reduce as square root of 5 times the square root of 3 divided by 4 times c. And this would be the velocity at which the object would need to travel to appear 1/4 as long to an stationary observer. And now let's go with part B. In part B, we're asked at what speed would the spacecraft have to be traveling to appear twice as long to a stationary observer. And as we know, this is not possible in special relativity, because what we are experiencing in special relativity is length contraction. As you can see from the length contraction formula, the length of an object to an observer that is at rest is equal to L0 times the square root of 1 minus b squared over c squared, as we mentioned before, where L naught is going to be the length at rest. So as you can see in this factor in 1 minus b squared over c squared, at velocity equals 0, this becomes directly L0, the length at rest, and there is no way for this length to be larger than L naught under any circumstance. So that would be all. There's no possibility in part B, so in B that is not possible due to length contraction, and that would be all. Thank you very much and have a good one.